Hello, welcome back to my series How to in my class CSC 120. Today we're going to learn about adders and subcircuits in LogiSim Evolution. Alright, let's get started. Even though LogiSim Evolution provides you the arithmetic adder to operate binary addition, I'm going to show you how to build your own version of binary adder. But first we have to build a circuit to add together 2 bits. This circuit is called the half adder. I'm showing you how it works. The circuits have 2 inputs, A and B. The sum of the 2 inputs is this output. I'm going to test it right now. 0 plus 0 is 0. 0 plus 1 is still 1. 1 plus 0 is also 1. But when 1 plus 1, we have 1, 0, right? The sum of the output will be 0, but we have to have another output to carry the carrier of the sum of A and B when the 2 inputs are both 1. That is called a half adder. This half adder circuit only allows you to add together 2 inputs. What if we have 3 inputs? For example, like A, B, and 1 carry from another binary addition. That's when we have the full adder circuit. So from the half adder circuit, I can build this circuit right here. This is called full adder circuit. It is made from 2 half adder circuit. Half plus half is 1, so this is called full adder. It has 3 inputs, A, B, and 1 carrier from another binary addition. It also has 1 output, it is the sum of the 3 inputs, and 1 carrier. If the sum exceeds the binary output 1. But how do I get this half adder circuit look like this? This is not something that provided by LogiSim. It actually my half adder circuits right here. As you build circuits that getting more and more complicated, you will want to build smaller circuits that you can use multiple times at a module nested within larger circuits. LogiSim provides you the tool to use the smaller circuits like this. It's called a subcircuits. It's like function in programming, or you can call like module, something like that. So if you want to use smaller circuits like this one, you just click on it and place it on the canvas. But how do I get this kind of appearance? Because I changed the appearance attribute in my attribute table to the customize. You can choose other appearance as well, but I prefer to use my own design. But how can you design that? You can right click on the subcircuits and click edit appearance, and you can mess around with the appearance of the circuits any way you want. Now let's go back to our full adder circuit. Let me delete this one and focus on the full adder circuit. The full adder circuit once again has 3 inputs, A, B, and 1 carrier. Since we have 3 inputs, we're gonna have a combination. So 0 plus 0 plus 0 is 0, actually, obviously, and we don't have the carry. 1 plus 0 is still 1 without carrier. But if we have 1 plus 1, the sum will go to 1, 0, right? So the sum is 0, but we have 1 carrier. What if we have 1 plus 1 plus 1? We have 1 plus 1 is 1, 0, and 1, 0 plus 1 is 1, 1. So the sum is 1, and the carrier is 1. the formula right here is not the formula, sorry. This illustrate you how the 4-adder circuit works. The C0, the carrier from another binary addition, plus A plus B will have the sum of the 3 input, and if the 3 input add together exist 1, which is like 1 0 or 1 1, then we'll have another carrier go to this output right here. The same thing goes for another combination of input like 1 0 1. This time A plus B is 1 plus 0, so the sum is just 1, but we will have to add another input Cin, so we have the total sum is 1 0, so the sum output will be 0 and the carrier will be 1, and that's it. That is how our full circuit works. After testing the 4-adder circuit and we see that it's working properly, we can use the 4-adder circuit to build more and more complicated adder with more than just 1 bit input. For this circuit, this is called a 4-bit adder. We allow you to add together 2 4-bit binary numbers. For this one, A3, A2, A1, A0, and B3, B2, B1, B0. Since the input is 4-bit binary numbers, so we're gonna have 4 of the 4-adder circuit. The circuit is laid out based on the longhand addition. As you look on this side, we can see that the first 2 digits of the 2 binary numbers, A0 and B0, will go to the first 4-adder circuit, as well as the Cin. Even though that for this number we don't have the carrier from any other binary addition, but I'm gonna keep this Cin in case that we need it for like maybe another 4-bit adder, so I'm just gonna keep it. You don't have to worry about this for this circuit only. So for this first circuit, we'll accept 2 input A0, B0. The sum of the 2 bits A0, B0 will be the S0. If the sum exceeds 1, which is like 1 0 or 1 1, we will have the carrier C1. The carrier C1 here will go to be added with the next 2 bits A1 and B1 in this part right here. So C1 go to the Cin of the second 4-adder. It's going to be added with the 2 input A1 and B1, and this circuit will produce the sum S1, and in case that the sum exceeds 1, like 1 1 or 1 0, we'll have another carrier C2, for example. The C2 will go to the next 4-adder circuit, and we'll do the same with the rest of the 4-adder circuit in this big circuit. So this circuit is once again is called the 4-bit adder, which allows you to add together 2 4-bit binary numbers. I'm not gonna test this circuit in this page right now. I'm gonna test it in the test adder circuits right here. Alright, after spending some time to change the appearance of the 4-bit adder, I have the 4-bit adder circuit look like this. It has 3 group of input. Cin, the carrier go in. The first number A, the second number B, and the output are the sum of the 2 numbers, and the carrier go out if the sum exceeds the maximum value of the 4-bit number. So let's test this circuit by selecting the poke tool. Right now we have 0, just 0 plus 0, so the sum is just 0 and no carrier. What if we have 1 plus 0? We have 1 and no carrier. This time we have 1 plus 1. So we have 2, which is 0, 0, 1, 0. Let's change this bit to 1. We're gonna have 0, 1, 0, 0. Change this one to 1. We're gonna have 1, 0, 0, 0. Let's change A to full 1, which is 15. Now we have 15 plus 1, which is 16. 16 exceeds the maximum value of the 4-bit number. So the sum gonna be all 0, but we have the carrier go out to C out like this. You can test this circuit more by clicking the poke tool and change the output. The input A and B. But I think it's working properly. That is my 4-bit adder circuit. The circuit looks a lot simpler than making the circuit from scratch from just logical gate and XOR. I got this good looking circuit because LogiSim Evolution provided the tool to build hierarchical circuit by using smaller circuit, which is called subcircuit. It allows me to make a very complicated circuit that's simple by just like using smaller circuit, smaller module. If we build the circuit, the 4-bit adder circuit right here with just logical gates like AND and XOR, we're gonna replace this 4-adder circuit like 2 half-adder circuit. So we're gonna have 8 half-adder circuit in total. It's gonna look something like this. I have a circuit called adder 4 complicated, which is also a 4-bit adder, but it's made from just logical gates and XOR. You can see that it is a lot more complicated to compare with our adder circuits right here. That is how you can use LogiSim Evolution hierarchical design with subcircuits to build more complicated circuit. Thank you for watching and have a good day.